Great to be here in Valencia. Actually, I was lucky to have one of my teammates with me, Paul here, and we traveled on our motorcycle to Valencia. It was a great adventure and a great start to, start this wonderful conference. So this is about operator lifecycle management. At Any9s, we do a lot of, building and automating application development platforms with a strong focus on data service automation. So we've been automating databases for nearly 10 years now. We did a lot of automation and do a lot of automation based on virtual machines using Bosch from the Cloud Foundry ecosystem as an automation technology, which is also declarative by nature, has a lot of similarities with building operators. And as part of that, we know that managing the life cycle of operators is very important because databases are often used for years, and that means you have to guide these database instances through their life cycle. So in this talk, we would like to have a brief look about at what does it actually mean to run operators for an extended period of times, and what are potential tools that could help us to do so. So first question is, what is operator lifecycle management about? And there are many facets to it. First of all, if you think about a more complicated operator, you're likely to have your CRDs, your controllers, admission controllers, all those bits and pieces that assemble your operator, including container images, obviously. And they all form some sort of contract. So a certain version of a controller is capable of reconciling certain versions of CRDs, and admission controllers also have certain version constraints. And of course, a lot of the magic happens within the container images, and they're also version constrained. If you think about databases and their life cycle, for example, Postgres, one of my favorite examples, we have customers who run applications for, let's say, 10 years. How do you guide a database instance through its life cycle for such an extended period of time? And it is pretty clear that at some point you want to take away, let's say, a certain database version, let's say Postgres 9.4. You would just want to, encourage your developers to migrate to a more recent version. So how do you do that with Kubernetes? Building an operator, you also have to upgrade your operators from time to time, for example, to deprecate a certain API version. And this is basically some of the facets when you want to manage an operator over an extended period of time. In particular, one of the sub-problems in managing operators is that of managing the lifecycle of your custom resource definitions. So if you, for example, again, think about a Postgres, then you'd have a CRD somehow representing your database instance. So if you introduce the first version, let's say as V1 Alpha 1, that's the API version of the CRD. It comes with certain capabilities, for example, a certain Postgres version. And at some point you introduce a newer version of that CRD. Well, you want to make the new version a default, and the more versions are added, the more likely it becomes that maybe you want to remove legacy versions from your Kubernetes cluster. Now, deprecating a CRD has been possible, I think, since Kubernetes 1.19. So you could mark a CRD as deprecated. So if you, let's say, do the Postgres V1 Alpha 1, you get a deprecation warning. So the next step you could do is to stop serving this version so that you can't create objects of that particular version anymore. However, if you look into an extended period of time, at some point you also need to migrate those objects that have been created already. Let's say V1 version 1, V1 Alpha 1 has been deprecated, it's not served anymore, but they are still service instances. What do you do with them? You need to migrate them, and it's surprisingly uncomfortable to migrate them. So there's some extra work you have to put in there. If you look at the process of upgrading such a CRD, you will see that you'll have to, for example, upgrade the CRDs, the objects stored in etcd somewhat. There's a migration tool for doing that, but it's not been maintained very well. Hopefully because there will be some inherent tooling in future Kubernetes versions to take care of that, so that your old V1, Alpha 1 service instances represented as those entities in Kubernetes etcd can be upgraded more easily. You can do that, with your own custom provided webhooks, but still it's work, and there would be nice if this would be simpler. Now, we at Any9s want to build several, operators and many other extensions. It is very likely that these operators will be deployed hundreds of times in hundreds of clusters per customer. So if you think about that magnitude, you will recognize that manual intervention of some sort is not desirable. It takes too long and wastes too much time of precious platform operators. So before digging into like building your own lifecycle management stuff, it makes sense to have a look at the tool landscape and think about technology that could do the trick for you. Well, the first guess, in our researches was Helm, with the slight feeling that Helm may not be the right tool, but because it's definitely the most popular one, it was the first one we actually considered. So here's some of the drawbacks. It's very popular and kind of mature because it's already been out there for extended period of time. It's rather easy to use. Provides you with a templating mechanism so that you can provide the end user with variables they can choose and provide as user provided values. It also has chart hooks, lifecycle hooks, so that you can do stuff pre-install and post-install, pre-upgrade and post-install. There's no server-side components, so you don't have to install anything into Kubernetes cluster to make Helm work. It's purely CLI driven. And of course, there's a wide range of integrations. So if you, for example, take a CI/CD tool such as Argo CD or Crossplane, then Crossplane has a different purpose, but still there's integration of Helm available, as it is the case with many other tools out there. So that's nice. However, if you think about managing the lifecycle of operators, you'll see that in particular, the lifecycle management of CRDs is not really good. And there are discussions in Helm on whether this should be improved, but so far it appears that Helm is just not meant to have a focus on this, and therefore the choice of Helm for this purpose is maybe not the right one. Also, it comes with limited dependency management. If you think about writing operators at scale, so we'll have several of them, for example. We not only have the operator creating the service instance, but we also have CRDs for representing the binding between the application and the service instance. We call that service binding, coming from the Open Service Broker API specification, as well as CRDs for creating backups and scheduled backups. So it is likely that some of these components will be shared to some degree. So chart interdependencies to install an operator framework and have shared components among operators would be desirable. So both of these things are actually no-goes and showstoppers for using Helm, at least from our perspective. Now, the other obvious choice is the operator lifecycle manager that ships with the OperatorSDK. It does have a server-side component. It's not really a problem, but it's just something that should be noted, because this server-side component has to be installed and lifecycle managed somewhat. It's designed solely for the purpose of managing operators. I mean, it's part of the operator SDK. It's kind of obvious. It also, well, the way you install in Operator with OLM is by creating a subscription custom resource, which also gives you the ability to parameterize the creation and the subscription a bit. But it doesn't provide you with the templating option such as Helm would do. One of the strong advantages of OLM is that it actually cares about managing custom resource definition lifecycle, in particular handling upgrades. There's still some manual work left for you, but it actually helps you a bit more. We also have Paul here, one of our engineers, who will be on Slack if you have more technical questions going into the details. And we are around the conference. I'm here at least for today and tomorrow, so reach out if you have further questions about this. And once you have, used OLM to automate the installation of the operator SDK will also help you to package up the OLM package that you've created. Well, there's some drawbacks. I mean, it's not a general purpose backup manager, so you have to stick with, you have to solve this problem on a platform scale with multiple tools or a combination of tools. There's no templating mechanism, so certain things like, I don't know, let a customer determine which labels to be set and so on will be harder to implement. There are workarounds for this, but it's I don't know, it's not as comfortable as a templating mechanism. There are no lifecycle hooks, so nothing similar to chart hooks. And upgrading custom resources still has to be done automatically. There's some support for upgrades. For example, the status version, stored versions field is upgraded after you have upgraded your CRs manually. Manually could still means that you have some sort of automation, but you'll have to provide it. The last option we've considered is Carvel. It originates from the VMware Tanzu platform. It includes CLI and a controller, so it has both a client and a server-side component. It is similar to OLM in what it can do, including upgrades of CRDs. Also provides templating. The fact that it has, app CRs, which play the role of subscriptions in OLM, somehow also suggests that maybe it has had at some point a stronger focus on apps. But the actual thing to consider here is that it is an early stage project. There's also no dependency management, which, as I said, may be desirable. And due to the early stage, there's little documentation and it's not widely adopted yet. So let's see where this goes, but it's actually a promising technology. The fact that there's no artifact hub or operator hub, I think is not a big disadvantage, but it still is one. And as I said, it's not as widely adopted. So where do we land with operator lifecycle management? I mean, the topic is much more complicated than the few things I've been able to present here today in a short period of time. So wait for some blog posts and material in our YouTube channel to come up in the near future about this, because this is something we'll look into for an extended period of time. So our conclusions are, Helm doesn't seem to be focused on operators. Carvel is promising but immature, and therefore for now we go with OLM. OLM potentially in combination with some sort of package manager for distributing a lot of OLM packages, a lot of operators in large platforms with a lot of Kubernetes clusters. But that's currently our educated guess for the near future. Also to say, from the perspective of developing an automation for data service operations, it is surprisingly technical and complicated at this point in time. The Operator SDK, for example, covers only a fraction of the things that you need when automating databases. So I'm really looking forward to see more tooling in that space upcoming, because there's so much more that can be done. So there's room for improvement. So that's it for now. If you have questions or comments, reach out. Thank you for your attention, and see you soon. Bye-bye.